Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. And tonight it's Calculus 2 where we're continuing this series on where did they get that formula. Specifically, we're going to look at this integral here, the integral of the square root of x squared plus a squared, and integrating that with respect to x. And it's supposed to equal all of this here. Whoa. Let's get after it, okay? How in the world are we going to come up with that? Now, the goal is for us to remember this. Now, in my case, I just know where to go look it up. I have an older mind, but you guys are young, you can do it. But when you see this integral, you're just supposed to write that down, not go through the full integration. So, that's the plan. Now, you recall in the other few videos we did where we've already looked at these two. We have this table. When you see one of these, you let x equal one of those, and then you end up using it in this manner. Now in our case, you can see we see this, so we're going to let x equal a tangent theta. So here we go. So let's let x equal a tangent theta. Dx then, if we take the derivative of that, a is a constant, the derivative of tangent is secant squared theta, chain rule, d theta. Okay? Now then, I can go back to my integral here, and I can say a tangent theta is x. So I have a tangent theta, and x is squared, plus a squared. Now dx, I have to replace it with a secant theta. I'll put that in parentheses. So I have a secant squared theta d theta. Okay? All right, we have a lot there. All right, let's go ahead and square this term. So we have the integral, the square root of a squared tangent squared theta plus a squared, all under the radical. Okay, you can hear the rooster crowing across the road. It's, what time is it? 1:45 a.m. I don't know why he crows at this time. All right, I'm going to pull this a and put it over here. And now I still have the secant squared theta d theta. Alright, so I have a times the integral of the square root of, and I'm going to factor an a squared out. Same as we did, very same concept as what we did on the other one. So I have a squared times tangent squared theta plus 1. So if I distribute the a squared in, I get this term here. And that's still times secant squared theta d theta. Now what is tangent squared plus 1? Secant squared. Okay, so you recall the rule, you know the rule, square root of a, b is the square root of a times square root of b. So given that concept, I'll go ahead and take the square root of a, bring it to the outside. So now I have a times a, you know, this a and that a, which gives me a squared outside times the integral. Tangent squared plus 1 is secant squared. Okay, so that's still under the radical times the secant squared theta d theta. Okay, now square root of secant squared, secant. Okay, so now I have a squared, the integral of secant theta times secant squared theta d theta. Oh, you recall, okay, a squared, I'll just rewrite this so we'll have it up here. Secant theta times secant squared is secant cubed d theta. Now just a few videos ago we had a video just on secant cubed. Do you remember that one? Well, it's a squared, that's our a squared here, times 1/2, put this inside here, secant theta tangent theta, so those are multiplied together, plus 1/2 natural log of secant theta plus tangent theta, and that's all in absolute value of. Okay, so the a squared times these 1/2. Well, what is secant theta and tangent theta? Well, you'll recall we had x equals a tangent theta. So x equals a tangent theta. If I divide both sides by a, I end up with x over a equals tangent theta. So if I draw a triangle, and that's theta, well, the opposite over adjacent is tangent. So what does this become up here? That's x squared plus a squared and square root of that. Oh, that looks familiar, doesn't it? Okay, now let's fill in the blanks here. We have a squared. Actually, I'm going to go ahead and multiply the a squared this into the various terms. This is one of my kryptonites, okay? And this is how I deal with it. I'm just going to put a squared over 2 times secant theta, and I'm going to also distribute that a squared over here. As a matter of fact, I'm going to do that right now. Okay, so now I've got a squared times that, and then a squared over 2 times that one. All right, here we go. Secant theta. You know, cosine is adjacent over hypotenuse. So secant's the opposite of that, the inverse of it. So I have the hypotenuse over the adjacent. So this would be the square root of x squared plus a squared over a times tangent theta, which was x over a, plus a squared over 2, the natural log of the absolute value of secant theta, which is the square root of x squared plus a squared over a, plus tangent, which was x over a, and the absolute value, sign closed. All right, so what do we have here? I didn't need that bracket, did I? Now I have a squared over a squared. So that cancels. So I end up with 1/2 times the square root of x squared plus a squared times x. All these a's just canceled. Now I'm leaving my 1/2 in there. Plus a squared over 2 times the natural log, the absolute value of square root of x squared plus a squared over a plus x over a plus c. Okay, this should be that. 1/2 x squared plus a squared, the square root of that times x, a squared over 2, natural log, yep, that's it. Okay, this, my friend, is where, in integrating this, that's where that formula came from. Why are we doing this? Hey, we're crazy. I don't know, I'm retired now, so I have some time, I think. Maybe when I was younger and I'm working a lot, maybe not so much. Okay, the table is critical. Either commit that to memory, and I would highly encourage you to do that, because when you look at these formulas, if you had sine square plus cosine square equals 1. Let's just say we have that. Sine square x plus cosine squared x equals 1. Well, what does that mean? Well, 1 minus sine squared x equals cosine squared x. So if I have some constant minus some x squared, constant, here we go. So this one, without looking here, yeah, so it's a sine theta. So you end up, the form somewhat dictates then how you can look at that and say, oh, okay, I need to make this a sine theta, and go for it. And you can see the same thing, like secant squared minus 1 squared. See, so, and then this one we just used was tangent squared plus 1 squared, or tangent squared plus 1 ended up being secant squared. So that's how you can work out from under that radical sign. So you end up with some function that gives you a square on the inside. You can take the square root of it and then work from there. Okay. Hey, together let's build a better tomorrow, and let's do that through math. Okay? Study, guys. Study, 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 and we'll talk to you next time. Thanks.